Good morning, students. In second unit, one of the most important problem in this problem also get previous question paper. This type of model question paper questions asking so many times. So please listen carefully. A unity feedback control system has an amplifier with gain K is equal to 10 and gain ratio G of S is equal to 1 by S into S plus 2. The feed forward path, a derivative feedback H of S is equal to S K naught introduced as a minor loop. G of S determine the derivative feedback constant K naught so that damping factor is 0.6. Here G of S, H of S also given. K is equal to 10, G of S is equal to 1 by S into S plus 2 and H of S is equal to S K naught. We have to find the value of K naught. So from this we have to find the first closed loop H of S, G of S by 1 plus G of S H of S, then multiply the K, then next find the closed loop feedback loop. Okay, 10 into G of S by 1 plus G of S into H of S. G of S by 1 plus G of S H of S we have to calculate, then we will get 1 by S square plus 2 plus K naught into S. Substitute here, then multiply 10, then we will get like this. Then calculate the unity feedback system, that is G of S by 1 plus G of S, 10 by S square plus 2 plus K naught into S by 1 plus 10 by S square plus 2 plus K naught into S. On this final C of S by R of S value is 10 by S square into 2 plus K naught into S plus 10. Already we know the formula for second order system, omega n square by S square into 2 zeta omega n S plus omega n square. Already we know the omega n square. Comparing both the equation, omega n square is equal to 10, omega n equal to root 10. From this, omega n value is 3.162 radians per second. 2 zeta omega n is equal to 2 plus K naught. K naught is equal to 2 zeta omega n minus 2. Already we know the zeta value 0.6 and omega n value 3.162. Substitute here, then we will get K naught value 1.7944. The value of constant K naught 1.7944. So this is one of the important problem. Then going to the next problem. A position control system with velocity feedback is shown in figure. What is the response of C of t? The unit step input given the zeta is equal to 0.5. Also calculate the rise time, peak time, maximum overshoot and settling time. This is the system is given. So C of S by R of S is equal to G of S by 1 plus G of S H of S. First find the C of S by R of S. Then we will get 16 by S into S plus 0.8 plus 16 into Ks plus 1. By simplifying this one also, 16 S square 0.8 plus 16K into S plus 16. Comparing the second order system, that is omega n square by S square into 2 zeta omega n S plus omega n square. So from this, omega n square is equal to 16, omega n is equal to 4 radians per seconds. In place 2 zeta omega n is equal to 0.8 plus 16K. In place of omega n, you have to substitute omega n value 4 and zeta value already given in problem, that is 0.5. Substitute here, then we will get K value 0.2. Substitute here in place of K 0.2, then we will get equation 16 by S square into 4S plus 16. Damping ratio is 0.5. So how to calculate all the rise time, peak time, maximum overshoot and settling time. So from this r of x is equal to 1 by s. Substitute here s into s whole square plus 4s plus 16. By taking partial backend, a by s plus bs plus c by s square plus 4s plus 16. The residue s tends to 0. C of s into s tends to 0. S into s cancel 16 by s square 4s plus 16. Here s substitute is equal to 0. 16 by 16, that is 1. B and C evaluate. Cross multiply the equation. Already we know the value of A. Comparing the s square terminals, a plus b is equal to 0. Already we know the value of A, so b is equal to minus a. So b is equal to minus 1. Next, equate the s terminals. 4a plus c is equal to 0. That is a value already know. C is equal to minus 4a. That is c is equal to minus 4. Substitute in a, b, c values here in this equation. So we'll get c of s equal to 1 by s plus s minus 4 s square plus 4s plus 16 is equal to 1 minus s by s plus 4 by s square plus 4s plus 4 plus 12. That is 1 by s minus s plus 2 plus 2. Just the 4 will be right, the 2 plus 2, and here also s plus 2 whole square, s square plus 4s plus 4. I can write as s plus 2 whole square plus 12. S plus 2 by s plus 2 whole square plus 12 by 2 by root 12. I have to write separate. Root 2 and root 2. S plus 2 whole square में 12. So apply the Laplace inverse of C of s. By s means 1. S plus 2 by s plus 2 whole square into 12 means e power minus 2t cos root 12t. 2 by 2 root 3 into e power minus 2t sin root 12 root 12t. This is a sine terminal, this is a cos terminal. So common the e power minus 2t, that is 1 by root 3 into sin root 12t cos root 12t. S plus b by s plus s plus a by s plus a whole square plus b square means cos e power at minus cos bt. Next, b by s plus a whole square plus b square means e power at minus e power minus at by sin bt. These are formulas. Okay. Then going to the sin theta. Here damped frequency omega d is equal to omega n into 1 minus zeta square. Already we know the omega n value is zeta value. So substitute here, we will get 3.464 radians per seconds. Rise time tr is equal to 5 minus theta by omega t. 5 minus theta value. How to find the theta values? Zeta already known. 1 minus zeta square already known 1. Cos theta value is 1 by 2. So from this 1 minus zeta square, that is 0.866. From this tan theta is equal to 1.732. Theta is equal to tan inverse of 1.732. That is 60 degrees. That is 1.047 radians. Substitute here theta value 1.047. Already we got omega d value. Substitute here, then we will get tr value 0.6046. Then peak time t equal to 5 by omega d. Already we know the formula. 5 by 3.464, that is 0.907 seconds. Percentage of maximum overshoot, that is e power minus zeta 5 by 1 minus zeta square into 100. Already we know the values of zeta value, so substitute here, then we will get the maximum percentage overshoot value, that is 16.3%. Then going to the settling time, first we have to calculate the time constant, that is time constant formula is t is equal to 1 by zeta omega n. Already we know the values of zeta and omega n values, so substitute here, then we will get the 0.5 seconds. In settling time, the percentage error is 5%. Ts is equal to 3 into t, that is 3 into 0.5, that is 1.5 seconds. In settling time, 2% error, Ts is equal to 40. 4 into 0.5, that is 2 seconds. Finally, the result is the time domain response c of t equal to 1 minus e power minus 2t 1 by root 3 into sin root t root 12t plus cos root 12t, and rise time tr is equal to 0.6046 seconds, peak time 0.907 seconds, and maximum overshoot time 16.3%. Ts settling time is 1.5 seconds for 5% error, 2 seconds for 2% error. This is the one of the important topic. So going to the